Okay, juniors, here we go. We're going to start up on the same standard that we worked on in class today. So we have standard 3.3. Polynomial inequalities. And here are our notes for day 2. All right, so in class we worked through 2 examples where we were able to graph them. So just a reminder, you don't have to put this part, so I'll put that in red on the board. But just a reminder, we had this question. And when we factored this, we got x plus 4 and x plus 1 were less than or equal to 0. Well, if we solve this, then we would think that, okay, x is less than or equal to -4, and x is less than or equal to -1. And some of you said that doesn't totally make sense. So when we looked at the graph, which looks something like this, then we saw that the only place it was less than or equal to negative or equal to 0 was in this area right here. So our answer was not what we previously had thought, but it was from -4 is less than or equal to x is less than or equal to -1. And then we wrote that in the way that we'll write it as pre-calc students in interval notation. And that would have been our answer. So we solved this using the graph to help us, but this standard is similar to one that you'll have in AP Calc next year, and this will be on the non-calculator section. So for the rest of the standard, we're going to do no calculator. So when we have a quiz, we'll have part of it with a calculator and then part of it without a calculator. So I'm going to show you how to do that today. So here's another example. We're going to write this one down together. So your notes will start with this first one. Solve the inequality. So example 1. All right, x squared plus 3x is greater than 10. So I can't solve this the way it is. So I have to get it have 0 on one side. So x squared plus 3x minus 10 is greater than 0. Now I'm going to factor the left side, and we remember our trick from class today. We'll do RS still. But we realize that as we do our RS, that it'll help us already find our factors. We get 5, we get -2, so we get x plus 5, x minus 2 is greater than 0. Now this is the part where we need to look at the graph, so to speak, to figure out where the function is greater than 0, where is it less than 0. So how we set this up is we'll actually just draw it on a number line. So we have a little number line here. Our zeros are at -5 and at 2. And so if you want to, you would label on top of those, you could just label them 0, just so we know. But that's pretty much why we plotted them anyway, so we won't really do that in the future. And we know what this looks like because we've graphed parabolas before with positive leading coefficients. But some of them, they'll get a little trickier because we'll do higher degree. So what we do is we're going to test if we plugged in a value in this given region. So if we test a value, like, I'm going to write in red again with my testing. You don't have to write this, but you could. I'm going to test -6. So if I plug -6 in, I'm going to plug it in just to the end here. So -6 plus 5 is -1 times -6 minus 2 is a -8. So negative times a negative ends up being a positive. So I only am using that number not to figure out the actual specific point, but to figure out if it's going to be positive or negative. Because I'm only asking, is this greater than 0 or is it less than 0? So a negative times a negative, we know that that is a positive. So to this side, we would have a positive. So you should write that. I'm going to get rid of all of the stuff in red. Good. Okay, so now let's test a point in the middle. Let's test 0. So I'll do 0 plus 5. Well, that's positive 5. And then 0 minus 2 is negative 2. So we have 5 times negative 2. We get negative 10, which ends up being a negative. So we'll write a negative here. And then let's try a point like 3. So if I plug 3 in, 3 plus 5 is 8. 3 minus 2 is 1. So I end up with a positive times a positive, which is a positive. And we're looking for, where are we greater than 0? So positives would tell me where I'm greater than 0. Negatives would tell me where I'm less than 0. So my answer would be this area over here and this area over here. Or we would have that with an open circle to the left, an open circle to the right. So that's how I would graph it, and then how I would state my answer. So sometimes we'll have to state our answer by graphing. Sometimes we'll state it with our interval notation. So because we're just greater than 0, we would say our answer is negative infinity to negative 5, parentheses, union 2 to infinity. Because it didn't have equal to 0, that's why we had to put our parentheses there. So this is our solution. Nice. Now we're going to try one that's a little more complicated. Here we go. Example 2. We have x cubed minus x is less than or equal to 3x squared minus 3. All right. So similar to the last one, we want to get this, we want to have one side equal to 0. So we're going to move everything over. X cubed minus 3x squared minus x plus 3 is less than or equal to 0. Now notice how well I did that. I put it in standard form, so our exponents are decreasing. And now I'm going to try left side, right side, because I've got 4 terms. So left side, right side, my factor over here, I've got x squared times x minus 3. I always bring down the third symbol. So this is positive, this is negative, so I'll bring down the negative. Negative 1 I can factor out, so then I get x minus 3 also is less than or equal to 0. And then we notice that those are the same, so we'll have x squared minus 1 times x minus 3 less than or equal to 0. X squared minus 1, we can factor that also. So we get our x plus 1, x minus 1, and x minus 3. So now we know that that whole thing is less than or equal to 0, but we've got 3 different parts there. So we're going to figure out what this looks like. So I'll put my zeros here. I've got negative 1, 1, and 3. So those are my zeros, and now I'm going to test values in each interval to see if that's positive or if it's negative. So I'm going to test a point. Let's test negative 2. So I do negative 2 plus 1, negative 2 minus 1, negative 2 minus 3. And really, all I'm looking for is if these create positives or negatives. So negative 2 plus 1 is a negative. Negative 2 times or minus 1 is a negative. And negative 2 minus 3 is a negative. So when I multiply those, a negative times a negative is a positive. And then a positive, so these would become positive, and a positive times a negative would be a negative. So this first interval would be a negative. So now let's try a different value to input. So I'm just going back through and going to try another one. So between negative 1 and 1, I'm going to try 0 because that sounds easy. So I'll plug 0 in. So 0 plus 1, that would be positive. 0 minus 1 would be negative. And 0 minus 3 would be negative. So a positive times a negative is a negative times a negative is a positive. So in this region, we'll get a positive value. All right, now let's try another number. Between 1 and 3. I like whole numbers, so I'm going to go with 2. So I'm going to plug 2 in here, 2 in here, 2 in here. So 2 plus 1 is positive. 2 minus 1 is positive. And 2 minus 3 is negative. So a positive times a negative, we'll get a negative value in that interval. And now I'm going to try my last interval. I'm going to try a value that is greater than 3. So I'm going to try 4. So 4 plus 1 is 5, which is a positive number. 4 minus 1 is 3, which is positive. And 4 minus 3 is also a positive. So I have a positive times a positive times a positive, which we know is a positive. So we have figured out on all the intervals, whether it's positive or negative, and we know where our zeros are. So our question is asking, when are we less than or equal to 0? Well, we're less than or equal to 0 when we're at a negative. So if we were to graph this, we would say closed circle to the left here. We would say closed circle and in between here. So that's what the graph would look like. And what the interval notation would look like would be negative infinity to negative 1. And this one, because it has the equal to part, we have to put the bracket. Union, bracket 1 to 3, bracket. So that is where we are less than or equal to 0, and that would be our answer. So you should write that down. All right, now here's one last example for us to really get our brains pumping. Okay, here we go. Example 3. We have x cubed minus 3x minus 2, and we're going to look for when that is less than 0. Okay, so we're looking at this and we're thinking, okay, that's x to the third. That's not a quadratic, so I can't do RS. But what I can do is that really fun standard that we did at the beginning of this unit, known as the rational root theorem. Very exciting. So we're going to come up with our possible zeros, because we need to find our zeros first. So we'll do plus or minus the factors of our constant, which are 1 and 2. Awesome. That makes our list very short. Divided by the factors of our leading coefficient, which is 1. So this one, our possible zeros are just this list, right? We've got 1, we've got 2, negative 1, negative 2. We have 4 possibilities, and we've got how many total zeros? You guessed it, 3, because it's a degree 3. So we have 3 zeros, and if they are real, or any of the real ones, are going to be these values here. Because it's to the third power, we know that one of them has to be real. So let's try one of these with synthetic division. All right, I'm going to try, let's try 1. So we have 1. Oh, remember, there's not an x squared term, so we have to put a 0. Negative 3 and negative 2. All right, bring down the 1, multiply. Add, we get 1. We multiply, we get 1. Add, we get negative 2. Multiply, we get negative 2. Add, we get, negative 4. That one didn't work. Okay, let's try another one. Remember, it's okay if it doesn't work, because we just tried 1. We've only got 3 left. They look like they should work. Okay, let's try negative 1. We have 1, 0, negative 3, negative 2. All right, we bring down the 1, we multiply. We add, we multiply. We add, we get negative 2. We multiply, we get 2. We add, we get 0. Awesome. Nice, that one worked. So we found one of our zeros. Now we have x squared minus x minus 2. Now for this one, I'm going to try to do a little RS action. So what multiplies to give me negative 2 and adds to give me negative 1. Let me think about that. Let's see, negative 2 and 1, perhaps? All right, so we have x minus 2 and x plus 1. Awesome. You can FOIL that out and check it. So we have this now in factored form. So let's go back. Here was our original polynomial. We found our zeros here. So our factored form, we would have x minus 2, x plus 1, and we had a 0 of negative 1 before, so that would be a factor of x plus 1 also. And we want to see when this is less than 0. All right, so now let's get to our line. We're at negative 1 and at 2. Because notice how 2 of our zeros are happening at negative 1. So let's test some points. All right, if we test a point, let's say negative 2. So negative 2 minus 2 times negative 2 plus 1 times negative 2 plus 1. All right, so negative 2 minus 2, we get negative 4 times negative 2 plus 1, we get negative 1 times a negative. So a negative times a negative times a negative, we know it's still a negative. So right here, we're at negative. Okay, now let's test a point between the two. Okay, let's, a point between negative 1 and 2, I'm going to try 0. So I'll plug 0 in for x. 0 minus 2 is a negative times positive times another positive. So a negative times positive, that's going to be a negative. All right, so we've got one more region we need to test. And that would be greater than 2. So let's test the number 3. So 3, 3, 3. I'd get a positive times a positive times a positive, which would be, times, really big times symbol, which would be a positive. And we can erase these, that part that we actually just did in our head. So right now we're looking for where is this polynomial less than 0. Well, it doesn't say less than or equal to, so we have to keep that in mind. So it's less than 0 on my graph. It would be less than 0 to the left of this, and then between those two zeros. So how I would write that would be negative infinity to negative 1, parentheses, union, negative 1 to 2, parentheses. And that would be my answer. So either graphically or written in interval notation, that would be my answer for both of those. So come tomorrow with these written in your notes, and we'll see you then.